If you roll a six-sided die and a four-sided die, what is the probability that neither die shows a 1? The grid below shows all the possible outcomes of rolling a six-sided die and a four-sided die. And we're fairly familiar with six-sided die. Those are the cubes that we're used to from the board games that we've been playing our entire lives that look something like that. And your roll is whatever is the face up. You're probably less familiar with four-sided die. These are more of like these triangular pyramids. They look something like this. So it has 1, 2, 3, and then the one side on the bottom. And here your roll is actually the side that is facing the bottom. And so what you have here is a picture of all the possible rolls. They have the six-sided die, the side that's facing on the top, and then on the triangle, this shows what is the result of the roll of the four-sided die. So this actually would be the side that's facing down. But let's actually try to answer their question, because they gave us all of the possible outcomes of rolling a six-sided die and a four-sided die. So we want to know, what is the probability that neither die shows a 1? So how many total outcomes do we have? Let's see, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 times 6, that makes sense. There's 6 possible outcomes for the six-sided die, 4 possible outcomes for the four-sided die, 4 times 6. So there's 24 total possible outcomes. And then how many of the outcomes meet our constraint? That neither die shows a 1. So this one, so anything in this row isn't going to meet our constraint because these have a 1 on the four-sided die, and nothing in this column is going to meet our constraint because these have a 1 on the six-sided die. But all of these, everything left over, these are going to meet our constraints. These are going to meet our constraints. And how many of these outcomes are there? Well, let's see, there's 3 by 4, 3 times 4. So there's 12 possible outcomes here. 12 over 24 is the probability. You could say there's a 12/24 probability, but if you wanted to write it as an equivalent fraction that's using lower numbers, this is the same thing as divide the numerator and denominator by 12 as 1/2. So the probability that neither die shows a 1 is 1/2.